All right, streaming. I'm continuing on my OpenFOAM project. I'm setting up oscillatory cases today. Oh, so, setting up the oscillatory cases. Prof just set me on the right path. Set me straight. There we go. Set me straight on the right path. I'm setting up the cases now, so I'm figuring out what dimensions and shit I have to put into OpenFOAM. I've managed to get my last oscillatory case working, so we're doing this. So it says that I should keep my Reynolds number for the flow. There's such thing as a net and an oscillatory. And net and oscillatory have two different definitions. So the instantaneous flow of the coil, or the oscillating flow to the coil at any point, is going to be the net velocity plus the oscillatory velocity. And Reynolds numbers is just defined in terms of those two velocities. And we're going to go with the max at this case. Max oscillatory Reynolds velocity and then net Reynolds velocity. Yeah. So, according to Ziprof, I've already got Reynolds number calculated here, which is nifty. Yeah, this is calculated from that. Okay. Okay. So I want to first calculate oscillatory Reynolds number, which is equal to 2 times pi. Fuck. All right. 2 times pi times density times the diameter of the tube divided by the viscosity of the fluid. That seems appropriate. Yeah, 2 pi. Oh, I am missing the amplitude. There we go. Oh, fuck you. All right. I need to actually lock these cells, dummy. Where's the frequency? Where the fuck is the frequency? Did I get it in here at all? 2 pi times the density, yes, times the diameter, yes. Divided by the viscosity times the amplitude. Okay, I completely forgot to fucking throw it in there. There, times, there we go. And the rest should be locked. Okay, that looks about right. Wonderful. So then Umax is going to be the velocity. So I'm pretty sure the oscillatory velocity is just going to be 2 pi frequency amplitude. In this thing it has sine, but if I believe sine 1 is 0. Why would it be at 0? Oh, because time t is 0. Okay. Yeah, so sine 0 is equal to 0. Oh. Well, that complicates that a little bit. Yeah, okay, I guess I don't know where the oscillatory velocity is coming from. U oscillatory. Meters per second. I guess it's going to be the maximum. I'll add a note there. Peak of oscillatory velocity. Where's a note? Oscillatory velocity. Okay. Peak of oscillatory velocity. So this should just be equal to 2 times pi times frequency times amplitude. And to make sure that's the case, I'm going to double calculate this using the definition here. So that's going to be Reynolds oscillatory number multiplied by, divided by, multiplied by the kinematic viscosity, which is the viscosity. Well, it's going to be multiplied viscosity over density. And then we're going to divide that then by the, okay. Going to take Reynolds number, oscillatory Reynolds number, multiply it by the kinematic viscosity, which is viscosity over density, and then divide it by the diameter of the tube. And those should give the same number, and they do. Wonderful. That needs to be locked, and then just drag this across. And so the Umax is then going to be this, lock it, plus the max oscillatory velocity. I'm also interested in the U-min as well, so we'll just calculate that quickly. Per second. And that's just going to be the same thing as here, but instead we introduce a minus. Okay, wonderful. That's what he said I should expect. I should expect it should give one pulsate condition and one oscillatory and two oscillatory conditions, which is what we see. This is pulsate, this is oscillatory. Oh, that's exactly what we were expecting. And this is for coil 2. I need to set this up for coil 6 as well. Shite. That's not how you spell coil, dumbass. Viscosity, coil length. D-tube. So this has got to go under coil properties. These are otherwise constants. Well, this one's dependent on... Yeah, this is dependent on... throw this up here. These are going to be uniform, the same across cases. These ones all change with different cases. Yeah, that's going to be dependent on diameter, and then diameter. So that's going to be coil 1, 2. This is going to be coil 6. Put a space in there, damn it. So I need coil length. That's hilarious. I just closed the thing I was using to calculate coil length. History, that one. I then need to find the dimensions of coil 6, which are that right there. So I need the pitch, number of turns. Oh, did I put in 16? You fucking dumbass. Coil length, that's better. Okay, yeah. Coil length. We're good. No harm, no foul. Close, shut you the fuck up. What? Why is it 17 now? I did not ask for that. All right, coil pitch for this one. Pitch is 20 millimeters. Coil diameter, which is decoil, is 362.9. Number of turns is 3. Calculate. Coil length, that's peach cream. I don't even actually know if we need that one anymore. What are the other dimensions here? Axial segments, it should be the same. Amplitude, I think we're also going to be 0.02. Diameter of the tube is going to be the inner diameter, isn't it? Yeah, so it's going to be 0.0. They don't really change. 681. Then I can calculate it from the same shit here. I just need to move that over. Fuck you. That gives me that. Okay. So then for this one, I just got to move these values. Oh, well, that can be moved over here. This here and this. Fuck you! That there. Butte. Need just a bit more space there. It's over. Calculating properly still. Butte. Oscillatory is just on frequency and amplitude, so that should be the same across here too. Umax. Ah, yes. That's going to be equal to U average. Lock that plus the above. Boom. Okay, so that gives us appropriate shit for coil 2 and coil 6. Oh. So, cycle periods, that's the right time. That's the period, that's the frequency, I believe. That's all the different periods that we've broken it up into. Or this is the frequency, 1.23. Oh, fuck. That must be the frequency, because then we invert it, we get units time instead of units per second time. Does that make sense? I don't know. Well, like that gives me the length of a period, and a frequency is just the inverse of a length of a period. Frequency. No, not a fucking film. Just give me what the fuck frequency means. Number of occurrence a repeating event happens per unit time. Per unit time. Okay, yeah, so if we get one full rotation in 0.81 seconds, it's 1 over that to get this. So that's our frequency. Boom. Okay. So yeah, that's our frequency. Hertz. Time for one cycle. Yeah, this is the time for one cycle. It's a period inverse of that. Okay. So yeah, this is our frequency. So based on the frequency, we get our right times, and then knowledge of which periods we average over. Okay. That's not what I'm looking for. We've got frequencies 0.5, 1.2, 0.5, 1.5, and 3. So 0.5, 1.5, and 3. Okay, so that gives us our right times. Still have to figure out dt. Sure, I'm pretty sure I can keep it like that. Okay. dt gave me notes on how to calculate dt here. Alright, CFL is equal to U max dt over dx. Adjust dt until CFL is equal to 1. I did just calculate the equation for this, so it shouldn't be a biggie. dt is equal to dx over um. dx is going to be equal to the length divided by the the length divided by the axial sections. That's going to give me the length in millimeters of, if I multiply this by 1,000, I get the length in, no, if I divide it by 1,000, I get the length in millimeters. Okay, dummy. All right. So that's the length in millimeters of each axial length. Not really, but close enough. At least the center bit, which is good enough. Yeah, that should be fine. So switch that over to meters. So then dt is going to be equal to dx over u maximum. For coil 2, lock that, divided by u max. And then we'll continue the same over here, but we'll just switch this for coil 6. All right. I think I should be able to start setting up the OpenFOAM cases now. And then after that, I gotta find these bits. Well, I gotta time average them, but you know, that's fine. Time averaging is actually gonna be a bit of a pain in my asshole. I also gotta figure out writing properly, that shit. But I am happy with what we've got here for this bit right now. So, setting up an oscillatory case. Which one is the right one? This one, coarse oscillatory. That's just control dict 2. That's just got all the other shit. Okay. So this is coil 2. What? Fucking. You're a handyman. 2. Yes. If we go back here and we do the undo. Fuck you. No, here. Why is this undo? That's so fucking dumb. Really, Excel? That's the dumbest fucking shit I could have imagined you program in there. Jesus. Okay, that is frequency. All right, wonderful. I want you to save. Yes. The fucking dumb shit Microsoft does sometimes just baffles me. Fucking baffles me. Testing matrix. Yeah, I'll just keep these both open for now. I don't know why I closed the other one. OpenFOAM cases. I need cycle periods. Yes. Christ. Okay. So this is, nope, this one. Then I gotta open up this one. Okay. So this is gonna be frequency 0.5. I'll have to rename this folder. I also want to get rid of most of this shit. I proved that this does write properly, but this is way too many files and it makes me want to fucking off myself. Come on. Almost there. The last file is 4.9-ish. Or handyman. All right, delete all that. Yes. Do 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 do. It's partially there. Do. I've got the camera way too fucking high. Oh, dog's about to lose his shit, I think. Yippee, there's my handsome face. Okay, no, you guys can hear me. I thought I had muted my mic for a moment in OBS. This is like, what the fuck? There we go! All fucking gone. Get out of here. Oh, post-processing. Yeah, I can kill this one too. That's fine. Did I save file? Save all? Yeah, okay, so the functions thing is saved. I commented out these two post-processing functions because they're not actually important to what I'm analyzing. I won't tell you what I'm analyzing because there's no one here to ask, so I'm not going to waste my energy on that. That would actually be a very interesting video. View my channel. Mute this site and then open this up so I can see what the fuck I'm doing here. Beauty. Okay. Now what I need to do is get all this shit into here. This is my control dict. I need to go to the 0 velocity input. Yeah, initial boundary condition. Yeah, these it is initial conditions. Okay. So this is coil 2. Radius can remain the same. Density is the same. Viscosity doesn't change. Reynolds number. We're doing just 10 to the 3 at the moment, according to Professor Helsig. Yeah, I would keep the net Reynolds number constant at 10 to the 3, and I would set amplitude to that. Okay. So it's just 10 to the 3, which at that point is just 1,000. Area of the tube should remain the same. Average should also stay the same. That should stay the same. Frequency, we're going to be starting off with 0.5. Oscillation amplitude, we're going to just use 2 for funsies. Omega, this is calculated from the other two, so it doesn't matter. What else do I need to keep track of? Now I need to go into the control dict to set the right functions. So dt, for this case, frequency 0.5 is going to be 0.0003. I can just copy that into here. This is going to be at frequency at C is equal to 0.5. End time. That's going to come from this one. End time is going to be 12. Your handyman. 12? Yeah, that would make sense. Yeah, because 2. Yeah, a period. A frequency. Yeah. Inverse of a period, yeah. So if it takes 2 seconds. Yeah, happens once every 2 seconds. Yep, makes sense. Right time. There. Fack off. All right. I just can copy paste that shit in here. So there is a problem with how shit's being written at the moment. So I have dt is equal to that, so that's going to be every time step. I don't want to do every time step. I want to write at every right time. Don't want to fucking put my WhatsApp chat history on stream. Oh, soup. Yeah. My ring's fitting a lot nicer today than it was yesterday. Yesterday I was cutting off the fucking blood to my pinky finger. By the way, I got my ring yesterday. I'm an engineer. Not according to any legal body, but I've taken the obligation and I have the fancy piece of jewelry, so that's got to count for something. Right time. Yes. So that's the dt, and that makes sense. Wait, does that make sense? What should happen is that the fluid velocity shouldn't be moving more than a cell at maximum velocity. So we can just use the calculator. So that's going to be dt over dx. No, dx over dt, dumbass. Okay, what's dx? Dx over dt, so 0.000599 divided by 0.003086. That's 0.194. And what's the max velocity here? 0.194. Okay. So that I'm guessing that means is that yeah, at the velocity of 0.194, the max it's going to move is dx, 0.599. So if we do Umax times this, that's the furthest it's going to go in meters, which is still the size of a cell, okay? Within the size of a cell. Okay, so that's peachy. That works fine. Yep. Got it down, baby. Yes. Okay, so dt. Set up. End t. 12 seconds. Sure. Right t. Mose. Settle your titties. No. What is going on out there, I wonder? I hear a lot of machines, so I'm guessing street sweeping at this point. Let me figure that out. Just a street sweep. We're all good. What the fuck is this? Alright, I'm gonna mute my desktop. Okay, yeah, that's fair. Brother was. I'm thinking about working while my brother's off at my parents' place, but he's just like, if you don't at all spend some time with me, like if you're only up while I'm gone, I'm gonna fucking strangle you. And I said, you know what, that's fair. This is not required. This is with post probes. That's not really necessary here. I do need to get fucking write times fixed up properly though. So I'm gonna set delta t. I'm just gonna reference dt. That should work. It was working before, but it was giving me a hassle. It should be write t, but whenever I do write t, it doesn't work properly. I'll try it again. But if not, I know what write interval is a some fraction of dt. So what I could do is figure out how many dt's are in a write t and do that. I can actually just fucking do that. So write t is 0.125, and we'll divide that by okay. 0.00308 That's 40.5. Okay, so every 40.5 dt's will get one write t. So I can just test this quickly, make sure I did my math right by multiplying that by 0.0030874. Good enough. Claire may need to be let in. Aight. I'm now streaming, doing my undergrad, and playing with the dog. We are on a roll today. That's roughly correct, but not quite correct. It's sort of fucked. 0030874. Oh, that's 8574. Oh, now it's on the fucking dime. And then if I multiply that by 2, we got 25. If I multiply that by 3, we're on a fucking roll. And if I multiply this by 12, 1.5. No, 16. Dami. 16. 2. Yes, that should get us a full cycle. Magnifique. Interval time step. Does right T even work in fucking OpenFOAM 12? Like, OpenFOAM right T. What the fuck? Right T keyword. Right dictionary. Okay, hold on. OpenFOAM. Foam control dict. That's V13. Time and data input. That's actually not bad. It's kind of what I'm looking for. Delta T. That's fine. I want version 12. Fuck. Which chapter was it? 4. Okay. 4.4. There we go. Input and output. Right. Is right T here? It is not here. Fuck. Yeah, that's the right interval. What I should be able to do is just define right T right here and then access it. Why are you being a little bitch? Zudong is still talking. Bro straight yapping. Oh. Typically, right time step, right control. What the fuck is right control again? Right control, adjustable time run. Time step, yeah. Okay, I can't fucking remember what the fuck anything does anymore. Start from, start time, start. Data writing. This is it. Write control. Controls the timing of write output to file. Time step. Writes data every write interval time steps. Ah. No. No. Okay. Okay. I need to stop licking my lips, otherwise they're gonna get chapped as fuck. Right. Alright, stop at, start from. First time, start time, latest time. Start time for the simulation with start from, start. Don't care. Stop at, no, okay. Delta T, time step of simulation. We got Delta T, figured the fuck out. We good. Yes. Data writing, write control. Controls the timing of write output file. Write control, time step. Writes data every write interval time steps. So, time step every... Okay, so what's going to happen is if I put it time step, that's why it can't be a fraction. It has to be greater than that. So that would be the 40 that I calculated here. I don't really want it to... I guess it sort of has to? Yeah. Writes data every, write interval time steps. So I have to define what write interval is. So that would be, writes every 40 time steps. So every 40 time steps using this DT is going to get me roughly 1.2 5, but I just want it to do 0.125. I don't, yeah. Runtime, runtime, writes data every run interval seconds of simulated time. Now that should be way simpler. Yeah, we'll do runtime. Runtime. Yes, and then that should be fine. And that should just be run t. And I believe that's what we have set up in the base case here as well. Write control runtime. Yes, that should be fine. That should work. But every time I've done this, it does not work. Is that everything I need to worry about for here? We've put in the Reynolds number, and that should give us our average velocity. Oh, fuck.